Greetings all, let's get rolling on antecedent variables and all the things that happen before the behavior does. We've already talked a little bit about these, we'll talk a little bit more. First off, we're going to focus on establishing operations. I hate this is a frustrating lecture to give because there's two different ways to look at this. So I'm going to present this to you as I first learned it, and then I'll talk about the differences between how I learned it and what is commonly talked about. So historically, establishing operations were just anything that was an environmental variable that affected that alters the effectiveness of a particular stimulus, of a reinforcer, or you could argue a punisher, but you don't really need EOs for punishers, right? Specifically, it alters the frequency of behavior maintained by that reinforcer, by that stimulus. Again, these things they happen before the discriminative stimuli, and keep in mind, when I first learned about these, I learned about them as establishing operations just as a whole. Well, nowadays what we do is we break it out into two different criteria. First off, we instead of calling the whole things establishing operations, we call them motivating operations. So basically, stimuli that serve as some sort of motivating function, and that can either establish the effectiveness of a reinforcer, or it can abolish the effectiveness of a reinforcer. So today, I think it's probably more accurate. I'm a little resistant to change on some of this stuff, but this is one I tend to agree with. So I think that motivating operations is the proper term to use. Motivating operations oversee everything, all right? And then you have the establishing operation within that, which establishes the effectiveness, and then you have the abolishing operation, which decreases the effectiveness of a given reinforcer. So that's essentially what we're talking about here. There's a few of these things that we can look at specifically. Remember, the focus on these motivating operations is that they are a value-altering effect. So all they're going to do is change the value of that reinforcer. If they decrease the effectiveness of the reinforcer, then we call them abolishing operations. You might wonder why there's a picture of condoms up here. Well, condoms are a classic value-altering tool. They tend to decrease the effectiveness of the primary reinforcer of sexual contact, right? So this is one of the reasons why people have a hard time consistently using condoms, is because they are abolishing operations. They're going to decrease the value of the reinforcer. Of course, you can set this up in a self-management perspective and say if there's you can either use a condom or there's going to be no sex at all. As a result, you end up with where it selects for that particular behavior, where even though the reinforcer has been devalued, it's still better than nothing, so to speak, right? So that's so condoms are an example of an abolishing operation. Other common examples of abolishing operations we'll talk about in a little bit, but usually satiation is kind of your key. So anyway, let's move forward. Or we can increase effectiveness through an establishing operation, right? The key with these things is that they happen before the reinforcer is delivered. Right? You can't have these things after the reinforcer because that doesn't make logical sense. Right? You can't have the effect before the cause. This is a cause and changes the value of the reinforcer. All right. Interestingly enough, it does not depend on learning history. So this is usually about states, or it's about states rather than traits. So if you think about the state of the organism, and that tends to be what changes the effectiveness of the reinforcer. And you don't have to learn that this particular thing causes that effect or not. It just does. All right. So that's the beauty, like satiation and deprivation, those types of things. You don't have to learn about what the effects of those are. They just have their effect on you. All right, so establishing operations by themselves. The easiest one, and probably the most common one that we work with, is a deprivation of a stimulus. Right? So we deprive you of something that's going to make that more valuable. Right? There's a ton of other ones, as you might imagine, but the trick is identifying them and figuring out which one's which. So we can sit here and talk or wax poetically about all these different establishing operations that may be out there, but the one that's going to be your go-to tool is probably deprivation. And it can be deprivation of any stimulus that makes that stimulus more valuable, right? So deprivation of television, deprivation of money, deprivation of food. In the rats and pigeon literature, we tend to use a lot of deprivation stuff with food to make the reinforcers more effective and just in general more useful. Right? It's not that food is not a reinforcer. It's just that to a hungry organism, food is much more powerful than if the organism is not hungry. Right? So again, there's a bunch of others. Think of them, but realize that this is something that we have to bring into the lab and really start to test and do a functional analysis on, not an assessment, in order to find out if they really are establishing operations or abolishing operations, for that matter. A simple abolishing operation, satiation, right? So if I make you full, if I give you a ton of ice cream all the time, ice cream's probably not going to be that much of a reinforcer anymore. It will get that way very quickly. You can bring it back to a reinforcer, meaning, my point is that you can bring that ice cream back to reinforcing value just by withholding access to it for a while. So this is a really common one. So satiation tends to be the key tool that we use with abolishing operations. So I give you a bunch of something, then it's going to reduce the value of it, of whatever it is that you're, whatever that thing is that I just gave you a bunch of. So there's lots of applications of this, but again, think about those, but think about what stimuli might decrease the effectiveness of a reinforcer just by having exposed to it. And satiation tends to be that big core. We can establish these things. We can, not establish, bad choice of words. We can play around with these a little bit, and then we need to look at unconditioned motivating operations and then conditioned motivating operations. So let's look at those. So unconditioned motivating operations, we've got right off the bat, food. So again, satiation deprivation situation here. Water, satiation deprivation. Sleep, satiation. You get the idea, right? Activity. These are all things that are unconditioned. And oxygen, of course. There's some interesting research on that one that I think your book talks about, how limiting people's access to oxygen by increasing the percentage of CO2 in your environment is basically an unconditioned motivating operation. It gets you to work really hard for the reinforcer, and the reinforcer in this case would be basically a breath full of healthy air, if you will. And I say sexy, sex is kind of the core here, but it doesn't have to be just sex. It can be other things that elicit those feelings, right? So any type of sexual activity, or it can be anything. Again, my brain I keep trying to avoid the word porn, but you get the idea, right? Anything that's sexy is basically an unconditioned MO, right? Too warm, too cold, increase in pain, right? That's an unconditioned motivating operation, or decrease in pain for that matter. That's an unconditioned motivating operation going in the other direction. But those are all ones you don't have to learn anything about. And I said earlier that these things don't rely on learning history, and that's true for all the ones that are on this list, but we do have other ones, and those are going to be conditioned motivating operations, and those are based on learning history in terms of conditioning, so that type of learning, or respondent conditioning type stuff through repeated pairings and stuff. So we'll look at those in a second. But before we get on to that, I want to talk a little bit about cognition and verbal behavior, because a lot of people, this is where this field starts to get a little quirky for some folks, because first off, the statement that we don't deal with cognitive events as behavior analysts, that's wrong. We do deal with cognitive events. We treat them as behavior by themselves, but they are not things that themselves are magical entities, right? They're behavior, and as a result, cognition and thoughts and things like that are explainable in all these terms that we've talked about already. And also, we need to explain them in their own right. We can't just assume that, the cognition pops up and there you go, that causes your behavior. That's kind of an irrelevant approach to take, right? And it's frustrating to think about that on one level. On another level, it's like, all right, well, our science is actually moving forward here. And so I say that cognition and verbal behavior are irrelevant. And that's not completely true on one level. On one level, they're behavior that need to be studied and explained. But it's not something that in itself is this super powerful tool that is a uniquely human thing, and so on and so forth. It's just another form of behavior. It's cognition is private verbal behavior. Verbal behavior itself is just what I'm doing right now, talking. And we know that talking is not doing, right? So that's why I say talking is irrelevant as well. So just because I say I'm going to do something doesn't mean I'm going to do it. Just because I think about doing something doesn't mean I'm going to do it. And interestingly enough, when you start to really dig into the literature, a lot of this stuff starts to, the cognitive decision-making processes and those types of things, they're called into question by a handful or quite a few studies that indicate that the behavior, whatever it is, tends to happen before you're aware of it. So meaning it doesn't, if we put it in biological terms, it doesn't get into that prefrontal cortex and all that stuff before you do the behavior. The behavior is already happening, and then you start to notice that you're doing it. So things light up in an interesting sort of pattern that's contrary to what we typically think would be the case. And being human and experiencing what you do experience, it feels like you think about something and then you do it. But the fMRIs don't always show that that's the case. They often show that the doing happens and then you're thinking about it. So kind of an interesting way to look at the world. Right? So description does not change the effectiveness. Point being is that just because you can describe reinforcement, punishment, and all that stuff does not change the effectiveness of it. Just because you can describe classical conditioning does not mean you can control it or prevent yourself from being conditioned. Just because you can describe punishment and reinforcement doesn't mean you're immune to punishment and reinforcement contingencies. Description is a verbal behavior that is reinforced and punished as well. So the description is just that, it's a description. So I'm no less or no more amenable to any of these principles as anybody else. Just because I know about it and I can teach about it doesn't make me special in any way, shape, or form. It's my behavior is still my behavior. It's shaped by the environmental contingencies, so on and so forth. Right? The stuff is automatic. Shaping, condition motivating operations, unconditioned motivating operations, classical conditioning, operant conditioning, all that stuff is automatic. Right? Sure, we can set up contrived situations as behavior managers, but that doesn't change the automaticity of it. Right? This is not something that the person goes through and decides that now a lack of sleep is going to make sleep more valuable. That's not the case. This all happens at a much more basic level than that, and we need to keep in mind parsimony as we continue with our science of behavior. Just because we want to make something complex doesn't mean that the complexity is really there. And oftentimes, if we go with a less complex solution, then maybe we can actually understand a little bit more about our behavior. And that seems to be the case. We've done really well with that by taking a very parsimonious view. That said, we started out with an extremely parsimonious view with a 3-term contingency. And now we've kind of added more. It's really a 4-term contingency now when you start looking at motivating operations, either unconditioned or conditioned. So the parsimony is there, and it's a guiding principle, but realize that it can be overridden with evidence, and with scientific and empirical evidence can change what we can change the complexity of our explanation of behavior. So again, to kind of hammer this point home one more time, is that just because you're thinking it and saying it doesn't mean you're doing it. They're two completely very different things, and that your understanding about this field does not change how well this field works, so to speak. It's not a bag of tricks. This is how behavior functions, and if you understand this stuff, then you can apply it, and that's the idea with the course. All right, let's look at the effects. Let's move back into the idea here of unconditioned motivating operations. So interestingly enough, an unconditioned motivating operation can actually be a punisher. Sometimes it decreases the response that preceded the UMO. It's an interesting way to think of it, because now, again, you're modifying the value of a reinforcer, but there was a response that preceded that motivating operation, so that motivating operation in itself can serve as a punisher. And now you're starting to see how linked in all these different contingencies are. So each and every contingency leads to another one, which leads to another one, which leads, and it continues on, and it's just this big, gigantic old cycle. And the point is that, wow, it's really hard to tease all this stuff apart. And yes, that's true. It is hard to tease it apart, and we got to do our best to do that when we're in the field. But sometimes sometimes we won't be able to tease all these things apart. So yes, a UMO can be a punisher. There's multiple effects on behavior. Again, it's serving as a punisher. It's also changing the value of a reinforcer. Abolishing operations can be reinforcers for preceding events. So establishing operations can be punishers, but abolishing operations can be reinforcers. So you're seeing these sort of opposite effects. So an abolishing operation decreases the value of a reinforcer, but that abolishing operation in itself can reinforce preceding events. So wow, it gets a little bit complex here, but the trick is just to utilize the tool. Now that you understand it, put it into use and say, okay, maybe I can use this deprivation as a so it's it would be an establishing operation, but because I used that motivation, but that motivation, I'm sorry, but the fact that I deprived you of something will likely punish whatever it was that you did right before that. So you get that sort of opposite effect going on, and it's a cool procedure. So it's just the nature of this stuff, though, and it can be a bit challenging. So. All right, let's look at something else related to motivating operations. Let's look at conditioned motivating operations. There are three types of those. There's the surrogate, the reflexive, and the transitive. So the CMO-S, CMO-R, and CMO-T, or SMOS, SMAR, and SMOT, whichever way you'd like to look at that. So let's look at the SMOSs. So this is a surrogate. Right? So we're going to pair a stimulus with an unconditioned motivating operation. So essentially what I'm doing here is establishing a conditioned stimulus, and that conditioned stimulus is now going to be, because of how you conditioned it and because of what you conditioned it with, it will become an unconditioned motivating operation. So food and sex, or food and some other stimulus, or whatever, it basically just follows that nice, clean, classical conditioning process, and you can take a stimulus and have it become a UMO by pairing it with other unconditioned motivating operation. Or I'm sorry, it becomes a CMO by pairing it with other unconditioned motivating operations using a classical conditioning pairing process. Again, you can reduce the effectiveness of this by breaking those links, right? Unpairing it, right? So if I have one stimulus that is always paired with so I have a CMO that's always paired with a UMO, CMO, UMO, and it kind of interchanges back and forth. Now we've established the effectiveness of that CMO. Now, if I just start presenting that CMO by itself, right, then the CMO is going to undergo an extinction process, and it's going to no longer be able to evoke the change in reinforcer value that a UMO does. So that's that. What's the term? That's how we can break that link. So that's the process by how that works. It really just follows a nice, clean, classical conditioning pattern. Right? SMORs, CMO-R. Right? These are conditioned aversive stimuli. Right? So conditioned motivating operation. What was the term? I always forget about what term some of these things are because I don't use them every day. The reflexive stuff. So the CMO-R is your reflexive. So conditioned aversive stimuli, a discriminative stimuli indicates, so let's just say a buzzer or something like that. So a buzzer indicates shock unless a response is performed. Right? So the CMO-R is going to increase the probability of that escape response. So the discriminative stimulus is indicating the shock, but then you're going to but that will become a CMO-R because it's going to increase the probability of that escape response. So it's going to be that escape response is then going to prevent the shock and so on and so forth, so it changes the value of the reinforcers. So just by adding this new aversive stimulus in your environment, you're learning that, hey, there's another response that's going to be reinforced that's going to terminate all these aversive stimuli. And and so any stimulus that precedes the discriminative stimulus becomes a CMO-R. So if the SD is a buzzer, then the operant or whatever environment is also around that's present when that buzzer happens is what becomes that CMO-R. So the SD is not the CMO-R in itself; it's the things that happen right before the SD. So you might be thinking to yourself, oh my gosh, is everything a CMO-R? Well, it can be, and it cannot be at the same time. So the point is that not everything out there that we experience is a CMO-R, but anything out there that you do experience could become one by pairing it with aversive stimuli. And all it's going to do is make that avoidance response more likely. All right. SMOTs. So it changes the value of another stimulus. So once again, so any conditioned reinforcer is a CMO-T. So food deprivation is your unconditioned motivating operation. We could pair a buzzer with that food deprivation, and now food deprivation is the CMO-T for the buzzer, right? So so you are literally making that pairing. It's similar to discriminative stimuli. But this is not the discriminative stimuli signal that a reinforcer is available. This is saying that that the reinforcer is going to be more likely, so to speak. It's not necessarily about availability. It's about probability in a sense. Right? So you're going to increase the value of you're going to increase the probability of responding in the presence of this particular stimulus. So any conditioned reinforcer in itself is a CMO-T. All right, let's dig into discriminative stimuli a little further. I know we've talked about them quite a bit. These are stimuli that that predict the presence of a reinforcer. So again, we're talking about, is that reinforcer available? Right? So it is a signal that says a behavior in this context will give you a reinforcer. Right? So when we do that, once that behavior has happened, we talk about stimulus control. So once you have been reinforced in the presence of one stimulus and not in the presence of another for a particular behavior, that's how you develop stimulus control. So responding to the discriminative stimulus means that you're going to make a response and then you're going to get reinforced for it. More importantly, the other side of stimulus control is that not responding when the S delta is present. So the S delta signals that no reinforcement is available in this context for a given behavior. So whatever behavior it is that we're talking about is not going to be reinforced in this context. So that is the S delta. So once stimulus control is developed, once you respond to the SD and you don't respond to the S delta. What's the limitations on discriminative stimuli? It's really simple, sensory capacity. So if you can detect it, we can use it to establish stimulus control. It can be a smell, sight, sound, whatever, right? So any sense that you have can become a discriminative stimulus. I mean, I'm sure you guys have by this point heard about I'm trying to think of the example, the blind guy that rides a bike. Right? And there's more than one person that does this. In fact, there's an entire training thing around this, and it's about essentially echolocation. Right? So we usually think of echolocation with other critters like bats and things like that, right? So echolocation, right? And you make a sound, and then you listen to that sound, and you can tell what's in your environment by the way that sound bounces back to you. And no joke, this can be done with humans. Right? And you've got folks out there, specifically speaking, there's some blind folks that have learned to ride bikes and navigate through their environment just by making those type of click sounds. And there's some interesting NPR things on it as well if you want to look some stuff up on it. But the point is that you can do that, and people learn how those sounds are different. Right? So I can, I'll give you an example how I make an easy one. Let's see if I've got a thick. Here we go. Here we have a thick thing. So you get the sound, right? So I can change the environment a little bit. Don't know how well it's going to come through on the computer, but the point is that I made some changes in the environment, and you should be able to hear a difference in the click. Right? So the fact that you can hear that difference in the click tells me that I can get you to, I can use that click sound, or those differences in that click sound, to establish a discriminative stimulus, and then go on to establish stimulus control. And again, the people that do this are unbelievably efficient at it. It's pretty amazing at what they can identify in their environment just by the sound that bounces back to them. So as organisms, we're very, very sensitive to discriminative stimuli, and pretty much anything out there can turn into one as long as you can detect it. Oh, and the other thing, this is kind of a side note here, but this is how we learn things like what colors do dogs see in, right? And what's the limit of a cat's hearing, or something like that. We establish discriminative stimuli and say, okay, can we establish stimulus control in this setting with this particular stimulus? Let's see how far we can take it. Right? So it ends up that dogs see with a slightly blue tint, and the cats can hear things that we can't hear. So can dogs, obviously, but you get the idea. So we can establish what range people can hear stuff and see stuff and those types of things. And it all boils down to sensory capacity. All right. Stimulus generalization. Of course, we don't always. It's not as clean cut as what I presented on every slide, so we make it a little more confusing here. So with stimulus generalization, this is responding to different stimuli in the same way. So there's a generalization, different stimuli, and you're going to respond in the same way. So it's stimulus generalization. The response is staying the same. So the response stays the same in the presence of multiple stimuli. Right? What this directly indicates is a lack of stimulus control, but at the same time it helps us function. So we'll look at how this helps us function. Everybody knows what to do in the presence of this, right? So right now, what would you do? Well, I hope you said, I don't know what the heck I'd do because all the lights are lit up, right? No, I'm kidding. You would stop, right? Why? Because all the lights are on, so it doesn't make any sense what's going on, so you make the safety response and you stop. Right? But we'll change that a little bit. Let's assume that the red light is what we're focusing, what we're orienting on here, and that's the one that's actually on. So in this case, if the red light is on, you know what to do. You stop in the presence of that. But not every light is the same. It's a little different. What about this one? If you saw that on the road and the red light was lit up, what would you likely do? I would hope you would stop. It doesn't matter that it's oriented in a different angle. It doesn't matter that the background is white versus black. It makes the yellow hard to see if the background's white, but you still know what to do. You still know to stop in the presence of that stimulus. Those are two very, very different stimuli. There's almost nothing that's similar about them. And there's even drop shadows and stuff like that on this one. Not that you really see that in the real world, but the point is you would know what to do. Right? Or we can do this pretty much the standard one. Right? You know what to do here, stop. You know what to do here, stop. Well, what's the difference between the last two? The red changed a little bit. The fact you know what to do, and the fact that you would behave the same way, and this is just demonstrating stimulus generalization. I'm sure some of you have seen the stoplights that look like this, right? They seem a little pink. Oh well, it's the location that you're probably responding to, and maybe even the color a little bit. It's some red tone-ish, right? So the point is stimulus generalization. And like the first one, in this case, you better stop, right? Because the light is broken. So there's all sorts of different you have the same response to all sorts of these different stimuli. I mean, I have 6 different stimuli up here, and you know what to do in the presence of all of them, and it's all the same response. So that's stimulus generalization. So what we tend to do as organisms is we tend to overgeneralize right off the bat. We tend to, once we learn one response that's going to work for us, we tend to try that response in a lot of different settings to a lot of different stimuli, and sometimes it works, sometimes it doesn't. When it doesn't work, then what we've learned, there is kind of a limit of that generalization. We found an end of the generalization gradient, which is what we're going to talk about in a second. So let's go ahead and talk about it. Let's pull it up. So what we've got here is a rough example of a generalization gradient, and on the x-axis you've got the training stimulus, which is dead center of that curve, right? And as you get further away from that training stimulus, the probability of response decreases. It's the steepness of this curve that tells us whether or not you have stimulus control over the behavior. So if the training stimulus has control over the behavior and only the training stimulus and everything else is an S delta, then you would have a very steep line that has almost no generalization gradient at all. There's not much generalization. But in reality, like with the stoplight thing, what you have is the training stimulus, the standard one that you learned about, and then there's all sorts of variations on that, and you respond the same way to all those. That's that generalization gradient going out to the ends, if you will. But the further you get away from that training stimulus, the less likely you are to engage in that particular response. So that's what the y-axis, so to speak, is the probability of your response. So let's see, what else did I want to say about this? This is, ultimately, we're going to get this into concept formation. But really, before we get into that, we're going to start talking about, I want to talk about the S deltas and the SDs and the stimulus control. So the generalization gradient basically says you're going to behave in the same way to a lot of different things. But as you learn that behaving in the presence of those other stimuli will not get you reinforced, those other stimuli then become S deltas, and that tightens this generalization gradient. So think of your life as being, put your life on this curve, and the curve tends to get tighter as the more you experience the world. In other words, you learn about your world. You learn that it's okay to do this in one environment, it's not okay in another. In fact, we joke about it all the time in terms of using your filter. It's like you tell somebody, hey, you need to use your filter more often. You need to learn to use your filter. What's going on is that you're saying that their generalization gradient is too broad. They're giving too much information or something like that. So you got a TMI situation, right? So they're giving out all these details, but it's not really needed right now. It's like, oh, I don't want to hear that. So that's the generalization gradient happening, and you're establishing the borders of that gradient. Historically speaking, the generalization gradients follow a normal curve. That's why I've got it up there. It's not perfect, but that's what you typically see. And we can demonstrate this in the laboratory. It's been demonstrated repeatedly in the laboratory with visual stimuli, with auditory stimuli, whatever it is. We tend to do the same thing. It's also a cross-species thing. It isn't just humans that do this. Pretty much every critter will. Here's a fun example that's uniquely human. So I asked the question, where is Afghanistan? Some of you may have heard this example before, some have not, but I'll use it again even if you have. So answer the question, where on the planet is Afghanistan? So give yourself a little verbal response there and drive your friends and neighbors and family nuts that you're talking to a computer. All right. My guess is, well, sorry. So then the next question. What ethnic categories? The Asian, the Arab, the Caucasian. What ethnic category are Afghans? Not Afghani, All right, Afghans. Afghani is the money. All right, so don't think that. So I'm betting that this might help you a little bit with both. So again, where is Afghanistan, and what ethnic category are Afghans? Take a look. Think about it for a second. All right, so a lot of people think that Afghanistan is in the Middle East. According to Wikipedia, this is the most traditional definition. This is the tightest definition. I'll grant you the fact that there's some broader definitions, but for this example, we're going to use the tight definition. The Middle East is right there. Now, notice Afghanistan. Notice this little thing out here. Right? Here's Iran. Okay, there's the Gulf. Okay, so you get the idea. And so Saudi Arabia down here, Iraq up here, so on and so forth. There's the Gulf, there's Iran, there's Iraq, Saudi Arabia. Where's Afghanistan? Right there, in the gray. So when you hear somebody say that Afghanistan's in the Middle East, feel free to correct them. It's not. So the question is, where is it? It's in Southwest or Southern or Central Asia. There's a whole bunch of different ways to describe this. So, as you might guess, it's Southwest Asia, right? So, a lot of people will call it Central Asian countries, and that's fine. They're talking about the vertical sort of thing. They're not the east-west sort of thing. But there it is. So, which means that Afghans don't consider themselves Arab. They consider themselves Asian. So when an Afghan, typically speaking, when an Afghan fills out a form on what their ethnicity is, if Afghan itself is not a choice, they'll tend to put Asian, and they'll definitely choose that over Arab. There's a lot of conflict between specifically Afghans and the Arab culture from the Arab Peninsula here. There's a lot of similarities between Iran and Afghanistan, as you might imagine. They're door to door there, but so there's a lot more similarities here. But the idea is that no, there's quite a bit of difference between Arab and Afghan. So typically Asian. Sometimes you'll get people to say Persian, and that's really common. So this is the Persian area, right? So this sort of region in here is getting a little big there. So this sort of region in here is Persia. You can go back to the ancient maps and look at what traditionally was Persia. So to be most accurate, they would probably say Persian, but Asian is kind of a current category that we typically use. So point being is that you were overgeneralizing, or most people, not necessarily you, but most people tend to overgeneralize this, and we think that everything in that part of the world is Middle East, but there's a lot more detail than that. I mean, even Egypt here is in northern Africa. Okay, so you've got to, so okay, is it Northern Africa and is it the Middle East? Well, it depends on how you define. Now, let's be honest here, and I'll fill in the story a little more. What we tend to refer to today as the Middle East is more of an economic impact zone, and it tends to cover kind of this whole region right here. Right, so the Middle East gets really big when you think about the economic impact zone. So you can go to Wikipedia and look that up, and that's pretty accurate, at least from my experience. So how do we take all this stuff to do what we call conceptual behavior? I hate the idea of concept formation because it implies that there's something being formed inside your head. In reality, it's a class of responses that where you do some generalizations and some discriminations and things like that. But the point is that in conceptual behavior, a young kid. May not have the concept of horse yet, so what are they going to do? They're going to say, dog. I mean, it's an okay mistake. Do you see that colt or whatever it is, and you say, that's a dog. Well, it looks similar to a dog. It's got 4 legs, it's got ears, it's got a big nose, and it's got a mouth, and it's got a tail, and it's kind of shaped like a dog, and it's a little bit bigger, but man, it's still a dog, right? I mean, you can put a Great Dane next to a Chihuahua, a teacup Chihuahua or something, and oh my gosh, there's a huge difference between those, right? Well, they're still dogs, so why wouldn't this be included as a dog? Well, there's some distinguishing factors, right? So in order to form the concept of horse, what we need to do is generalize within the categories of things called horses. So everything that's a horse we generalize within it. So not all horses look alike. There's differences. You've got draft horses. You've got miniature horses. You've got quarter horses, and all these different types of horses. You've got tons of those things, but we still call them all horses, right? So we're generalizing within our class, as we say. So that concept formation is developed. So we're generalizing within, but then we have to discriminate between classes. So you have to learn what isn't a horse, in other words, an S delta, and what isn't a dog, in other words, an S delta, right? So we learn what is a horse, there's an SD, and what isn't, there's an S delta, and then as we learn to behave properly, what we're doing is we're generalizing just on those key characteristics and then discriminating based on other key characteristics. One of the characteristics right off the bat that you can discriminate with between a horse and a dog, just look at their feet. That's an easy way to tell. There's other ways to tell as well. The shape of the snout and the shape of the head and all those different types of things is different than a dog. And there's a bunch of other criteria as well as you might think about. But that's really how we go about forming concepts. It's really just a discrimination procedure. You're learning a discrimination and generalization procedure. You're learning what is what and what isn't what. Right? And then once you can accurately do that, we tend to say, you've formed the concept of, right? But just keep in mind, this is also not something that's uniquely human. Pigeons do it, rats do it, all sorts of critters can do it. In fact, it's somewhat humorous research to see how pigeons and what concept that pigeons have of humans, and you can kind of identify that by once you teach them to respond to the presence of a human, then you start to vary what that human characteristic is, and you get some really interesting sort of things. And feel free to look it up or come to the office and chat about it. All right, equivalence relations. This is directly related to all this stuff as well. So I'm going to talk about a match to sample procedure. This is something that a lot of kids will do for fun, believe it or not, and they're doing an equivalence relation procedure. So with equivalence relations, what we're doing is we're establishing the equivalence of two stimuli. In other words, it's a special type of generalization. So with a match to sample procedure, we're going to present a stimulus and then choose from other stimuli one that matches the sample. Pretty straightforward. Say, okay, I'll show you the truck. Now choose the truck from the list, right? That type of thing. Or here's the letter A. Pick the letter A from the list. And you get the idea. So I'm teaching you what letter A's are. And I can present, the A in cappuccino here is different than the A here. So I'm teaching you to generalize there. So the point is that we can do that match to sample thing. So choose, and here's the matching stimulus, or here's the training stimulus, so to speak. Now I want you to match it. Right? So that's a really basic match to sample procedure. Now we can take that and build on it, and this is where humans start to really shine. Right? This is one of those things that not all of this is uniquely human, and I'll talk about which stuff is and which stuff isn't here. Right? Reflexivity is what we just talked about. I'm going to show you an A. I want you to pick an A. So stimulus A equals stimulus A. So show you a truck, pick a truck. Show you coffee, pick coffee. That type of thing. Right? Symmetry. It's a little more difficult. Okay, most creatures do reflexivity, by the way. That's not hard for most species. Right? But symmetry, on the other hand, is A equals B. So I'm teaching you that the coffee cup is the same as the coffee functionally. Right? So I'm saying I'm going to show you a coffee cup. I want you to pick something that's related to it, and you pick the coffee. Right? So then I should be able to turn around and show you the coffee and have you pick the coffee cup in return. Right? That's symmetry. Okay. Again, quite a few species will do this as well. Other species, not just humans, but it gets a little challenging for them. It takes a little bit of effort. So here's where humans are really starting to separate themselves out from other species. So kids, and so if we think about this in terms of kids, younger kids are going to have a hard time with A equals B and then B equals A. It's an equivalence relation procedure. B does equal A because you taught it when you taught them that A equals B, but now you have to flip that thing around. And hopefully they'll respond to A when you present them stimulus B. And transitivity, A equals B and B equals C. If so, then A equals C. And of course you can flip that around and go then C equals A as well. This is very challenging. This is hard to teach anyone, even a human. Humans learn it, but it's a difficult task to learn this sort of stuff. So you have to do quite a bit of training. So if the coffee beans equal the coffee cup, and the coffee cup equals happiness, then happiness must equal coffee beans, right? So you get the idea. So let's do some examples of these. this is some slides taken from another course, and it demonstrates these equivalence relation procedures fairly well, but keep in mind this isn't the type of thing we would normally do with a kiddo, but you get the idea. All right, so the sample key, this is basically just going to show you what you need to respond to. So again, we're going for reflexivity and we're focusing on color. So sample key is red, and then normally the organism needs to make a response. So if you're teaching a kid, they got to basically identify that they saw the color red. So they say, so you could easily say, tell me what color it is, and say, okay, red. Right, so they saw it. Right, then you take a little time break. Then you give a few seconds. 5 seconds, 10 seconds, 20 seconds, a minute, an hour, a day. That time break is essentially sets up a remembering situation, a memory test, right? So I give you the sample key, I turn it off, which is or you make an orienting response, and then I turn it off, and then I give you the option, right? Matching comparison key or the non-matching comparison key. So this is reflexivity, A equals A, so we're going for a color match, so you need to match the color. Right? This is the type of stuff we do with kids that are developmentally delayed or autistic or something like that. We need to be able to teach them about their world. So we just start off seeing if they can do this basic thing, and then we go from there. So eventually they learn that, okay, red equals red, and I'm going to get reinforced if I choose the red circle. Right? We could do reflexivity in terms of shapes. Okay, which one was the matching comparison key? It was a very short time break, and I didn't present that key very long. Let's do it again. There it is. So the idea of matching comparison key is the triangle. So the sample key was a white triangle. Interestingly, here, different people cue on different things. Some people cue on the fact that there's a triangle there. Some people cue on the fact that it's a color of a triangle there. So if we were doing this in a real setting, we would basically vary the color of that triangle to teach the people that it's form, it's the shape that matters. Right? So again, this is how we start to develop. With reflexivity is really how we start to develop concepts. You should be getting that idea by now. All right, here's an arbitrary match. This is symmetry, and an arbitrary match, meaning that we just picked something and we're matching it with something completely else. So there's something completely different. So now red is being tied in with the triangle and not the diamond. See, there goes that yawning again. And then we get the reversal test. After we train that, we should be able to say, okay, the red or the white triangle equals the red key. Okay. And then here we go, our transitivity. We're going to work on color to shape. Here's some color to form. So red is going to be tied in with triangle. Now triangle is going to be tied in with a light key. So form an intensity, if you will, so the key is not as bright as the other one or as dark. So the non-matching comparison key is dark. The matching comparison key is lighter in color, so it's brighter, so to speak. All right. So we did red equals triangle, triangle equals light color. Now red must equal the light color, and then we reverse the whole thing to make sure they really learned it and go light color should equal red. All right, so that's kind of how we do that. Again, this is set up more in an operant chamber with pigeons and rats type of thing, but you can imagine how we would do this with kids. So let's take it back into the kids situation. Right? So errorless discrimination. This is a procedure that we can use to help people learn these discriminations and learning the difference between one stimulus and another, and learning a difference between one concept and another. Right? So the point is that we want to reduce the chance of making errors. So basically, the point is that I give you no opportunity to make a mistake. Right? So ultimately, the way to do this is to introduce the option stimulus, but you do it gradually. You do it slowly. Right? So if I say, let's say I'm teaching the kid about trucks and cars. Right? So I've got a bunch of matchbox cars or whatever they're called, and I take these things and I show them the truck. Right? Then I have other cars in my hand. Right? But then I take the truck and I put it on the table. I just put the truck on the table and I kind of hold the other cars in my hand nearby it. But don't let them really, the point is they can't grab the stuff in my hand. Now I say, choose the truck. And the only option really for them to do is choose the truck, because the truck is the only thing on the table. So next what I'll do is I'll put the truck closer to them, and then I'll take a car and I'll stick it close to me. So on the truck is close to them on their side of the table. Now the car is close to me on my side, and say, okay, choose the truck. And then again, they're successful. And then I slowly start to bring those two stimuli close together. So choose the truck. And I always reinforce them if they're appropriately choosing the truck versus the other car. What tends to happen, though, is a side preference. Right? So the side preference is that if you always put that truck on the left side of the kid, they're going to learn that it's the left side that is the truck. They're not going to learn that that's where the truck is. So the way you do to deal with this side preference stuff is to, what do we say? We change where the truck is in our example. So normally, let's say I started out with the truck on their left, and once they get that right, then I'll move the truck to their right, and then once they get that correct, I'll move the truck back to their left, and so on and so forth. And you're forcing them to follow the truck rather than just choose left, 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 left. And of course, what I just set up there was a left, right, left, right, left, right sort of scenario. So you would almost do it randomly. So you would do, okay, the truck's on the left this time, then the truck's on the right, then the truck's on the right, then the truck's on the left, and then you slowly start to change that stimulus. And you can also start to change the stimulus with multiple trucks, and change that, instead of always using the same little toy car, you can use a different truck. So maybe a purple one, or maybe one that's bigger, or one that's smaller, or those types of things. So that's an errorless discrimination procedure, and it works really, really well, especially with developmentally delayed kids. All right, well, fading. Let's deal with this one. So fading is about changing the stimuli in order to select for a different response, right? So we're going to start with one stimulus, right? And then we're going to change the properties of that stimulus until the desired discrimination is being made. So I've got a school example set up here. Maybe. Somehow. Come on. Work. I hit the button. No, it's making me hit it one more time. There we go. All right. We're going to set up a fading procedure to teach someone what 10 times 20 is. 10 times 20 is 200. So I asked the class, 10 times 20 is what? Everybody says 200. You can do this with one person. Now I say, 10 times 20 is what? I say 200. But notice that I'm changing that stimulus a little bit. 10 times 20 is what? 200. 10 times 20 is what? And you might think about it for a little. Oh, it's 200. 10 times 20 is what? 200? Of course it is. Good job. Well done. You're making the discrimination. So you've learned that when you see 10 times 20, you write the answer of 200. And we did that by fading out the 200. So we slowly faded it out, right, until that desired discrimination is being made. So we can do that with all sorts of stuff. Writing. You guys have all seen this with writing. Think about elementary school and teaching kids to write. Think about that. This crazy lined paper, right? You've got all the gigantic spaces between them, and the red dots and the green dots and all those funny lines on there, and then over time you get rid of all of those lines and you move to just the regular rule, whatever that is, wide ruled paper, right? So you move to that, and then you move to the college ruled paper, right? So those lines are getting really tighter. What we're doing is we're fading out those stimuli. We're changing those procedures to make sure you write within a particular area and making a particular discrimination of it. Here's how high your letters need to be, here's how much space needs to be between them, and all those types of things. All right, well, that's about it for antecedent stimuli. So I will talk to you again, and we'll talk about whatever the next topic is. I think it's going to be on shaping, things like that, shaping and chaining. Anyway, take care.